Great. So I think let's start this game by starting with 3 gold bars, right? Because 8 is a bit too much. So let's just try to grasp the idea of this game, and then we'll move on to some of the harder levels. So yeah, let's try to find the real gold bar. Anyone have any ideas for which ones we should weigh first? Go ahead, Kimmy. You can unmute.
First we do A and B, and the heavier one we do B and C. So if A and B, the heavier one is B, then we do B and see which one's the heaviest.
Okay, so you're saying like this, right?
Yeah, and then we weigh it.
Okay. Huh, they're the same weight.
B is just a bit heavier. So that means
What does
if
that mean?
how
Give me
we
st
do B and see if C's heavier.
Okay.
So the real gold is C.
That's right. Okay, let's see if that's true. Let's see if that's true. Uh, go for gold. C. Bam. Okay, congratulations. Nice. We found the real gold bar with 2 ways. I will say though, we actually didn't need to do that second way, right? Because when you found that A and B were the same weight, we know that there's only one real gold
That
bar,
means C must be the real bar.
right? Every other one is fake, and the gold bar is heavier than all of the fake ones, and the fake ones are all the same weight, which means that we already know C is the gold bar. Um, so yeah, we really needed one way, but still, congratulations, Kimmy. You nailed that. All right, why don't we try 4 gold bars and see if it's still possible to do one ways. Does anyone want to try this one? Go ahead, Jasper. A and B. So A on one scale and B on one scale, right? That's what you're saying? Okay. All right, let's weigh it. Ooh, looks like they're the same weight. Okay. Is there anything we can conclude from that, Jasper? What does that mean if they're the same weight? Okay, you want to weigh C and D now? Okay. Right, exactly, Jasper. A and B are fake. Oh, well, I guess we found the
I
answer, huh?
think we can do
Which
it
one do you think is
differently,
real?
right?
That's right. D is real. Sorry, what was that, Kimmy?
I think we can do it differently, right? We can do A, B, and then C, D. And to add it up, if there's two fake golds, if each fake gold is 4, each real gold is 8. 4 plus 4 is 8. That means one side will be 8. The other side will be more than 8. That means one side will be heavier.
Kimmy, I think I lagged a bit. Would you like to um here, let me replace my hotspot. You want to quickly state that again? I lagged a bit, sorry.
Yeah. So first we put A and B, and then we put
Okay.
C and D on one scale.
So like this.
No. I mean like A and B on one scale and C and D
Oh,
on one scale.
okay.
Then we would know because if the gold is heavier, that means it would add up to an even heavier amount.
Right. Okay, so we're weighing this.
So that, yeah, so we would see that C or D is heavier. And then we weigh C or D.
Okay. Oh no. Okay. That's good strategy. Yeah, for sure. And then whichever one is the heavier one, we know it's the real one.
Oh, it changes it?
Well, we restarted the game, so this time it's C. But yeah, I think that's correct. Congratulations. Yeah, you can weigh two at the same time. That's right, Jasper. So it seems like the minimum number of ways we need is two ways, huh? It's not really possible to do one way. Um, okay, well, why don't we try five gold bars? Can we still find the real one with two ways? Anyone can feel free to just jump in. Just tell me which one you want to weigh. Okay. I think that's an interesting idea. We can try that. Right. So this is using Kimmy's idea from earlier, right? If you have two of them and one side is heavier, then you know the gold one is belonging to the other side. So in this case, since
We weigh
D
the
and E were
last two.
heavier, right, it's one of these two, and we just have to weigh them again
And then
to
if those
find
two
them.
are the same, that means C is the one with gold.
Right, exactly. Right, so I think we found the goal in this case. The goal is D. Nice. All right. What about for six, though? Can we still do two ways for six and still find out? Is that possible? Does anyone have any ideas? Joyce or Leo or Loy? Do you guys have any ideas? How could we weigh these two? Okay, Kim is suggesting A, B, C and D, E, F. Okay, I think that's interesting. So we can weigh these three and these three. What would weighing these three tell us, Kimmy?
The three, if one of them is heavier, that means one bar and these three of them are gonna be a gold bar. And then we just weigh two of them together. So if those two are the same, that means it's the one that's left on the top.
Right. Okay. I think that's smart.
So D, E, and F are heavier. Now we just
Right.
weigh D and E. If
And this
D
just
and E are
becomes the
the
puzzle
same,
from the
then it's
very
F.
beginning, right? Okay, so it's D. Nice. Right. So I think in this case, it's almost like, like a recursive relationship between the number of gold and the number of ways, right? Because if you can weigh three of them at the same time and you can locate that, exactly three of them contains the gold bar, then that means you can just apply the idea you had when we started with three bars, which only needed one way, which means that six bars, you only need two ways because one plus one equals two. I think that's really cool. Good job, Kimmy. So for seven bars, could we still do the same thing? Because theoretically we could still weigh three bars, right? And we could weigh the other three bars. And if both of them are the same weight, then that means we found the gold bar, right? It's simply D, the one we didn't weigh. But if they're not the same size, then it's basically the puzzle that Kimmy just solved. And we can just apply the same ideas to find a real gold bar in 2 steps. So it will look something like this. Okay, so obviously EFG contains the real gold bar, which means that we would empty all of this and we would weigh exactly 2 of these. And we can once again find the gold bar within 1 step. They're the same weight, so that means G is the real gold bar. And we have once again found the gold in 2 steps, which is great. Okay. So I think this is worth noting down because there might be a cool pattern that we can find. But 3 bars, with 3 bars of gold, how many steps did we need? 1 step, right? One way. Um, with 4 bars, how many weigh-ins did we need? We needed 2, right? Is that correct, everyone? I think 4 to 7 bars all needed 2 weigh-ins. So I'm just gonna write this little note down here, just in case there's a pattern that we can notice. All right. What are you guys' predictions for 8 bars? Do you think we could still do this in 2 weigh-ins, or would we need 3? 3. Okay, Leo. Um, would you like to go ahead and try this out? You can feel free to draw on the board. Which ones would you like to weigh? A, B, C, D, and E, F, G, H. Okay. I think that's a great idea to start with. A, B, C, D, E, F, G, H. Okay, let's weigh this. Okay, so E, F, G, H is obviously heavier. Um, now what? E, F, and G, H. Okay. E, F, and G, H.
Or we could just do two of them. It's
Two.
gonna be the same number of steps.
Right, exactly. Because now it's just like the thing we applied for 4 of them. So that means GH was heavier, so one of them is the gold bar. So we just have to do one more weighing. And it's G. Nice. So the gold bar is G, and that is
我们有 ID。对
okay,
呀，
nice.
Can I ask what is the max number of
Sorry, Kimmy. What did you say?
what's the max number of gold that you can put on?
I think that's a great question. Let's find out.
No, you can go 30.
30.
Wait, you can do more scales?
Yeah, but that becomes a little weird. Let's do all of the possibilities of this, okay? But I do think that we don't have to do every single situation because with 9 bars, I think what happens is like
It's
you
the
weigh
same
A,
thing. You
right,
just
A
need
to
30 and
D, F to I, and that's one weighing, and then you need if we get lucky, it's E, but if we don't get lucky, then it's F, G, H, I. You weigh F and G, H and I, and that's another weighing, and you need one more to find the actual one, so it's 3. And I think that with 5 bars, would do the same thing because you do A through E and F through J, and that's one weighing. And you would do F, G, and I, J. It's another weighing. If you get lucky, it's H, but if not, you need another weighing. So that's 3 again, right? Um, with 11, it's pretty much the same thing, I think. You would do 5 bars, 5 bars. That's 2 weighings. If you get lucky, it's K. If it's not, you need another weighing to do 2 bars and 2 bars. If you get lucky, once again, you're done. But if you don't, you need another one. So that's 3. So I think up to 11, it's 3 bars. I mean 3 weighings. But what about 12? Is that still 3
Can
weighings?
I ask something?
Yeah.
What after they run out of the after they run out of the letters, like after 27, what are they gonna use?
Oh, that's a great question, actually. Um, yeah, let's find out. We'll get there. Oh, hi Zion, hi Bella. Basically, we're playing this game in which we're trying to find the gold bar amongst um all of the fake ones, right? And so basically there's only one real gold bar amongst all of these gold bars. Everything else is fake, and the gold bar is heavier than the fake ones, right? And you're trying to find which one is real with a scale. And basically, here's a real quick example. So if you have 3 bars, you can weigh one of them and another one of them, and you see that they're the same weight, which means that they have to both be fake, right? Because there's only one gold bar that's real. Everything else is fake, and all the fake gold bars have the same weight, and all of them are lighter than a real one, which means that C is the real gold bar. Does that make sense? Okay, good. And basically so far we found that with 3 bars you need one weighing and 47 bars you need 2 weighings. I think Kimmy and I realized that 12 bars you need 3 weighings as well. Is that right, Kimmy? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Um, just for educational purposes of moving, because there's other aspects of this puzzle I want to explore with you guys. I'm just gonna test this out real quick. So theoretically, you need one way in first, right? So, okay, this group is heavier, right? So Xeon and Bella, obviously the real gold bar is on the red scale because that one is heavier.
I'm pretty sure you
So,
need 3 to 4 if you're unlucky.
let's find out. And you need another way in to find out whether it's in this theory group or this theory group. So, okay, so it's in this one. Oh, but no, you actually just need 3 because in this case it becomes that initial one we had earlier. Remember, it's just this case. It's the 3 bar scenario, which means that you really just need one more bar at max, right? Because if it's if J and K are the same weight, then L is the fake bar. But since K is heavier, K is obviously the real one. So we really just need 3 weigh-ins. But the question really is, what happens when you have 13?
Now it's gonna be like 4 to 4 bars, I'm pretty sure. I mean like 4 ways.
Hmm. Does
Yeah,
anyone want to try weighing this?
I'm thinking you do 6 on each scale. And there's
I
gonna be
think
one
that's
left over. So if we're lucky, it'll be that one. But if we're not,
那是啥呀？就这题啊，你看懂吗？啥？
sorry for joining in. It's not muting their mics. It's okay. Um, yeah, so I think Kim, I think that's a great idea, right?
so that means the leftover is not the real one. So we have to go the farther away.
Right. So that means the leftover is fake, and one of these ones are real. So we'll just weigh these in a group of 3, right?
Yep.
Right. So that's another weighing. So that's what. Okay, so JKL is
I think it's K, isn't it? Just by guessing. Oh no, you
maybe
added
it
it one
is.
extra.
Yeah. Let's find out.
Um,
Oh no, it's actually
okay.
J. So, okay, but this is really interesting, right? Because we found that even with how many bars is this? One, two, three, four,
13.
five. Right, with 13 bars, we can still do 3 weigh-ins. So I guess really the question is, at what point do you have to have 4 weigh-ins?
I think around 14 bars is a thing. 14, we're going to do 7 and 7, which will break it up into another 3 and 3, and there's going to be 2 left. You're gonna have to do 4 and 4.
We can test that theory. Let's try that. Okay.
Oh no, I
So
think it's
this
16. 16 you need
16.
4
Okay, we can
4
try
ways.
16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, yeah, let's try that. So, I'm
8
assuming you
on
want to
each
start with
scale.
8 and 8, right? Okay. Oh, sorry.
And they stack this up in a really goofy way.
Yeah. Okay, so this is weighing number 1, and we know that it's on one of these other ones. Okay, so not bad. 1, 2, 3, 4, and 1, 2, 3, 4. So I guess we'll weigh these, right? You're like eliminating them one by one.
So now we know it's IJKL. So now we do IJ and KL.
Okay.
Yeah, so it's gonna take 4 ways.
Right. I think that's right. Oh shoot. Right. And you need one final weighing to find the real one. So for 16, you do need 4. Right. So it's K. But I think the question is, does that mean with 15 you only need 3? Let's find out. What do you guys conjecture? Do you think 15 will need 3 or 4?
I don't know.
Oh
We gotta
well, then
wait and
let's
see.
let us find out. I think there's actually a really cool pattern going on here, and maybe some of you are starting to see this. Okay, this is way number 1, right? And as usual, we'll weigh,
Oh, you still do need 3. You can still do it in 3. I'm pretty sure.
right? And then if we get lucky, it's N. If it's not lucky, then we'll have to keep weighing, right? So we're not lucky. So it's one of KLM. But again, we only have to weigh one more time because with 3 bars, you only need one weighing. So in this case, it's K, and this is the maximum number of bars. I mean, sorry, weighings that you need. Um, okay, I think this is really interesting, and there is clearly a pattern going on here. Um, 18 bars means that you need 3 weighings. And I have a conjecture for what this pattern is, but I wonder if any other one of you see this pattern. There's a clear pattern going on here in terms of how many bars needs how many weighings. Does anyone see the pattern? There's a mathematical pattern. Okay, I'll say that. There's a mathematical, or if you want to, algebraic pattern within these numbers. And I wonder if anyone sees it. Okay, I'm gonna highlight these numbers just to make it more clear. Does anyone see a pattern?
Yeah. No, I think they're divided by 3. No, they're divided by themselves. Never mind.
Hey, but that you're kind of on the right track here, Kimmy, but it's not quite 3. It's a different number. Okay. Is everyone stuck on this one? Any ideas before I give a hint? Okay. I'm gonna give you guys a hint, and I think this will make it really obvious. Um, I'm going to write over these numbers, and I'm gonna add one of them. I'm gonna add 1 to each number.
I got it. I got it.
What's the pattern?
So like 3 times. No.
Oh, Bella, that's
So if
actually a
you
great
add,
observation. Yeah.
never mind. Oh no, I
So,
get it. So if you add one and then multiply by two.
right, yeah, I think a better way actually to think about this is actually this. You want to think about what time they change, right? So if you do this, one way, okay, I think with 2 bars, right? 2 to 3 bars, you need let's write it this way. 2 to 3 bars, you need one weighing, right? With 4 to 7 bars, you need two weighings. With 8 to 15 bars, you need three weighings. I think this is much more clear. Um, here. I think now it would make a lot of sense.
The first one is times two. But you don't
Right.
get
Look,
it the second one.
exactly. These are all powers of two. Look at that.
No, but they're technically not because 3 times 2 is 6, not 7.
No, not multiples of two, powers of two.
Oh yeah, I get it now.
Right. And I'm only looking at the first number, right? And in fact, it's like a perfect relationship for the blades, right? Because if you want to get a bit algebraic and you want to name this a function, then if you define a function w, actually I'm gonna write this up here. If you want to define a function w in terms of the number of bars, it is actually exactly 2 to the b, right? So if you have 2 bars, um, sorry, no. If you have, okay, I don't think I read that correctly. If you have 2 bars, that's 2 to the 1, right? And 4 is 2 to the 2, and 2 to the second power, and 8 is 2 to the 3, right? Does that make any sense? I guess what I'm really trying to say is you have to notice that 8 is really 2 to the 3, right? 2 to the third power. 4 is 2 to the second power. And 2 is 2 to the first power, right? And if you look at these exponents, it seems that they match over here. Does this make sense to everyone? Is everyone else seeing this? Right. And so I think,
So
based
it would
on this
be 16
conjecture,
to something.
right, exactly. So I think, based on if we continue to extend this, then we could say, oh, shoot, I don't want to do that. Okay. Then we could say
I'm
that,
pretty sure it's 16 to 31.
right, so 16 bars to 31 bars would be how many weighings? It would be 4 weighings, right? And then 32 to 63 bars would be 5 weighings. And 64 bars to 127 bars would be 6 weighings. And we can't necessarily confirm all of this with 127, but we can go up to, oh, I don't want to, what was that? But we can go up to like 30. And I'm betting that it's going to be 4 weighings. Oh, Kimmy, so that's how they do it. It's double A, double B, double C, double D. Um, yeah, so why don't we try this real quick? Um, right, the conjecture is that it will be 4 weighings, but let's find out if that's true. Let's find out that let's find out if we can weigh this thing with only 4 weighings. So as usual, you want to start with half of them, right? And you do the other half. Okay. And then naturally, one of them will be heavier because the real gold bar is one of them at least, right? So it's in the second half. So we empty all of them, and now we do the same thing, except that now it's 7 instead of that much. So we weigh this, If we get lucky, they're the same weight, but we're not lucky, so we have to do a third weighing with these. So 1, 2, 3, 4, 5, 6. I hope that was right. And finally, these three are the heaviest. So STU, that was the third weighing, right? And with STU, we already know that we only need one weighing for this because, again, with 3 bars, you only need one weighing. So in this case, T is the heaviest. So we found that the real gold bar is T. Nice. So with 30 bars, we only needed 4 weighings, and that confirmed our hypothesis. Okay. So clearly, our conjecture is correct, right? The pattern goes like this. Would anyone like to try to explain why this pattern is the way it is? I'm going to delete all of these extra gold bars so you can see the text. Would anyone like to try to explain this pattern? Feel free to type in the chat, but I would love if you could unmute yourself. Dion, Justin, do you guys see why this pattern is happening?
Is it just
Or maybe
two?
Bella and Joyce?
Is it just like 2 times 2 times 4 times 8?
Yeah, the point is that they're exponents of 2, but like I'm trying to ask, why is this pattern happening? Like, why are they exponents of 2? Like why is it the case that they're exponents of 2 instead of like, I don't know, 3, you know? Why is that the case?
I'm not sure. It's like well, because would we need 3 for like we would need to get 3 gold bars left to find the answer, right?
Right.
Yeah, so uh hold on. Well, I'm not sure. Yeah, I'm not sure.
That's okay. That's okay, Zion. That was great. Leo, would you like to try? You can attempt to explain it. We'll see how you do. Okay. Would you like to unmute yourself? That'd be a lot easier. Or I suppose you could type in the chat. Okay, you type it. I'm going to explain my intuition with this, but um we'll see if your explanation kind of matches up with mine, okay? So I think what's happening here is that with every single type of, with every single number of gold bars that you have, you can always clear away half of them with one weighing, right? For example, if you have 10 gold bars. No, actually, you know what? Let's do 16 for the sake of this exercise. Okay, if you have 16 gold bars, you can get it down to 8, right? With one single weighing, right? Because you can do this and weigh the other half, and you will find the gold bar within one of these piles, right? And that gets you down. That gets you down to 8 gold bars with one weighing. At this point, it becomes 8. But with 8, you already know that you need 3 weighings, which means that for every jump by a multiple of 2, right? So 8 times 2 equals 16, or 16 times 2 equals 32. You really just need one extra weighing, right? you really just need one extra weighing because you can always clear away half of these with one weighing. So it's like a relationship by a multitude of two, which is why there's this exponentiation of twos happening in that three, because the scale only have two sides, right? But if somehow the scale had three sides, right, like one, two, three, you can weigh three piles at the same time, then in that case, it would be a multiple of three, right? And you would see like 3 to 8 bars and 9 to 26 bars, and there'll be exponents of 3. But in this case, since you can clear away half of the pile every time with one weighing, it's showing up in multitudes of 2. Does that kind of make sense to everyone? Are there any questions about this?
Nah.
Okay, great. Now that we kind of like solved this basic puzzle, I think that we should mix it up a bit. What do you guys think?
3 bars, 3 scales.
What did you say?
Can we try 3 scales?
Sure, we can try that. There's also this other game mode of lighter and heavier, which I do want to play around with. But sure, let's try more scales first. Let's try 2 scales. Okay. Obviously 2 bars is too little, so why don't we try 4 bars?
Can you weigh them
Uh,
without anything in them?
sorry, what was that?
Can you weigh them without, like, can you weigh them right now
Sure.
without anything in them?
You mean like just wait like
Yeah.
that? It's nothing's gonna happen. It's just
Oh.
yeah. Um, but I do feel like for this one, it's pretty intuitive. You just weigh every single one of them. And it's a single way and you get the answer, right? Obviously the answer is D. I mean, sorry, obviously the answer is A, right? So it's A. Okay. I think if you have 5 bars, it's really the same thing, right? If you have 6 bars, um, it still really is the same thing because you can still do it in one way. Um, does anyone see how you would do this with only one way? Or I guess not one way, but like one use of both scales. So you don't go back for a second weighing, but you do use both scales to weigh. Any ideas? I think Jasper and Justin, do you guys have any ideas of how you would weigh this with 4 scales, and not for 2 scales, but only one way? Yum. Jasper, I would encourage you to think about it like this. I'm not going to tell you the answer, but I do want to give you a hint and see if you can figure this out. And I'm going to give you a hint by covering this side of the puzzle. How would you weigh this? I'm listening. Right, exactly. You would weigh A and B, right? You'd put A here, B here, and if they're the same weight, you know it's C. If they're not the same weight, then you know it's one of the heavier ones, right? So what would you do if I suddenly erased this other half and show you that there's the exact same thing on this side. What would you need? What would you do now? C and D. Okay, sure, we can try that. Okay, so in this case, it seems that A is the heavier one, which means that we can conclude that A is the gold bar. Great job. The only concern I have is what if in that time we got lucky, right? But what happens if you weigh these, you weigh these four and say they're all the same weight? Then that means E and F.
That means you would have to wait ENF again.
Right. So that means we would need two weigh-ins actually. And so that actually changes it. So let's see if nope. Okay, we're too lucky, but theoretically, if you're super unlucky, that could happen. And you have to have two ways.
So if you did C and E, you would have to measure D and F again.
C and E. Right. Exactly. So if you measured this there, like say you measured this at first, then you would have no idea if you would have no idea which one is the real gold, except that it might be D or it might be F. And in
You
that
could take
case, you
your
would actually,
chance, or you could be really smart and measure.
right. So you would have to do these. And in fact, I think like with this little game, you can actually do that. And whichever one dips the further. Oh, it actually doesn't. Okay, you can't do that. Yeah, but the idea is that you would then have to weigh them together for one more time to find out the real one. So in this case, it's B. Um, why don't we try a more extreme version? Let's say 20. Actually, no, let's do 16. How would you weigh this one? How could you find out which one is fake? Sorry, which one is real in the least number of ways with the scale? Joyce, were you gonna say something? Go ahead. Joyce?
I have an idea.
Yeah, go ahead.
So, so how many bars are there?
16.
So 4 so 4 on each scale.
Okay.
It's easy. Just divide the number by 4. That's how you have
Right.
the bars to put on each scale.
Exactly.
But if but if it was an odd number, like something that wouldn't work, then you'd have to like leave one. So that means we know that A, B, C, D is a one of them has a real gold. That means we first do A and B, then C and D.
Right.
In full
Exactly.
scale, we can do it quicker. Just
Or
A,
in fact, you could just put one of them each, right? Because you do
yeah,
have two
yeah.
scales. Okay.
So now the one that troops the most is the real gold. So it's D.
Right. So that's actually really cool because with 16, even with 16 bars, you still only need two ways, which is really cool. And in fact, I do think that there's a similar pattern going on here. And I do think that it has to do with powers of four, right? So with this one, I think it's 4 to 15, you need one way, and 16 and above, you need two ways. Is that correct?
I'm pretty sure. I'm pretty sure if you get to like 90 or 30, you're probably gonna need 3 ways.
Right. I do think so too. Okay, I want to play around with this puzzle a little more And they do actually have this other mode in which it's lighter. Okay, with lighter, basically with lighter, it means that the real gold bar is lighter than all the fake ones, but that's really like kind of the same idea, except you just see which one is lighter. But
That
I
is
think
so
what's
fake.
yeah, but I think what's really interesting is if the gold bar could be either heavier or lighter. And I guess the question in that case would be, how would you still know which one is real and which one is fake? So I just want to spend like 5 more minutes playing around with this scenario, and then I'll let you guys go. Okay. So in this case, what would you do? Say you had 4 gold bars and you wanted to figure out which one is real, but the real gold bar might be heavier or lighter. What would you do in this case?
So now there's a problem. The 2 and 2 won't work now. So you're gonna need to measure each of them by their own. So A and B, and then you gotta measure B, C and D.
Really? I mean, what would happen if we did this theoretically?
So if it's lighter, we might think that might be the fake one. If it's heavier, we might think that might be the real one. And maybe when it's lighter, it's the real one. Maybe it's if it's heavier, then it's the fake one.
Right. So basically this doesn't really tell us anything, right?
Yeah, so you would need to measure it by one.
Right. Definitely. So let's say we just do this first, A and B. So we know that one of these is fake, but we don't really know which one is real.
So then we would do B and C and see if they're
Right.
still both heavy.
For the sake of consistency, I'm just gonna do A and C, but it's the same idea as yours.
So now we know that
Okay.
A and C are the same. That means now we measure A and D.
Actually, I think Kimmy, we can stop here, right? Because if A
Yeah,
and
but I
C are the
think
same
one is
weight,
probably B.
right? I think B is the golden bar. Right. Okay. Good. But you can clearly see that in this case, you need a lot more weigh-ins, right? You need two. Um, yeah, why don't we try 6 bars? How many weigh-ins would you need for this one?
6, I think. Oh no, 5 or 4.
You need 5 weigh-ins?
I think. Be like A and B, and then A and C, 2, A and D, A and E.
Hmm.
Yeah. Oh no, 4 ways, I'm pretty sure.
Yeah, that's definitely possible, but I wonder if there is a faster way that we could do this.
Oh, or I can do A and B and then C and D, and then A and B and then E and F.
Huh. Okay, let's play around with this. Um, if we do A, B, C, D, E, F, that doesn't really tell us anything, does it? I think that wouldn't really tell us anything. But if we did A, B, and C, D, would that tell us anything?
Yeah, one of them will be heavier, one of them will be lighter.
Right. And then if we were to compare this, say that A and B is heavier, we then compare this with E and F. Could that tell us anything?
Yeah, so if they're the same weight, that means the real one must be in C and D.
Exactly. So I think in this case, let's try weighing this.
They're the same. That means it
Right.
must be E and F. So now
That's
we
right.
make E and F. Oh, we should
Okay, but
make
I
E and
do
F.
think that if you weigh E and F, it's not going to tell you anything, right? Because obviously they're going to be different, but you don't know which one is the real one.
Yeah, so you would measure E and A.
Right. Okay. Okay, so
So
E is the same as A.
E is fake. So the real gold
Right.
is F.
That's right. So in this case, F is the gold. Okay. Um, great job. I think we've honestly figured this puzzle out. Is there anything else you guys want to explore?
Can we do 30 bars and the max number of scale?
Sure. Let's try it out.
That's 6 scales. Hot day.
Oh, okay. All right, then this is the final challenge of the day. What is the minimum number of ways you need to find the gold bar within 30 bars and 3 scales?
This
Let's
is
do
gonna
it.
be so painful.
It is. It
The
really
first
is.
one's gonna be 5 in each thing. But then it's gonna
Okay,
be
and it's okay.
so
I'm gonna make it heavier just so it's not too hard. So in this case, the gold bar is heavier, okay?
what is 5 in each scale?
Yep, I think that's a great idea. Oh my God, it's a lot of clicking. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Okay. All right. Oh, you actually, um, I think we're actually done, right? Because it's the fake one. I mean, the real one is
Oh, it's
almost
actually not as painful as I thought.
right. Because remember with the
Now
pattern
I
that
know
we found,
that U V W X Y.
right? Because remember with the pattern that we found,
That means
we
the
know
real
that,
one is X.
right, the number of weigh-ins you need is directly based on the number of scales, right? And so if you have 6 scales, then that means even 6 to the 2, which is 36, you would still only need 2 ways. So, this app doesn't allow for that because it only goes up for 30, so you can't really see like the full ramifications of this pattern. But I do think that we figured out this pattern, which is great. And great job to everyone. And thank you very much for coming and have a great weekend. Bye, everyone. Good job. Bye, Kemi. Great job.
Bye.
Bye. Bye, Leo.